Okay, hey, welcome back. We're going to take a look at the effect of the orientation of the crosstalk barrier on the dual element straight beam probe. And we're going to take a look at our half-inch thick side drill hole block and the 300 thousandths thick notched block, which those blocks look something like this. Alright, so our side drill hole block has 4 side drill holes. It's a half-inch thick, 500 thousandths. There's a couple of notches on the ends, 50 thou and 100 thou notches. So the 4 side drill holes, the center of the hole is at 100 thousandths deep, 100, 200, 300, 400. And then for the notched block, the notched block is 300 thousandths thick, and it's got, let's see, I think 8 notches. 1, 2, 3, 4, 5, 6, 7, 8 notches. And the shallowest notch is only 10 thousandths of an inch deep. Then they go 10, 30, 60, 90, 120, 150, 180, 210 thousandths deep. And when we do this little experiment with the orientation of the crosstalk barrier, we're going to look at the notched block upside down, so to speak, with the notches on the bottom. And let's go ahead and use this other one if I can get this to stay here. There we go. So we're going to go ahead and put our straight beam probe right over the top of the 210 notch. And the depth to the top of that notch is only going to be 90 thousandths. If this is 300 thousandths thick, and the depth of that notch is 210, then the depth to that notch tip or top is going to be 90 thousandths. The depth to the top of this one will be 120, 150, and so on. So we're going to go ahead and take a look at the side roll holes in that notch with the crosstalk barrier either parallel or perpendicular to the notch. All right, let's go ahead and do that. Okay, we're back to our trusty flaw detector. We're going to go ahead and see, just observe the effect of the orientation of the crosstalk barrier on the straight beam dual element probe. Let's go ahead and do a fresh recall on our straight beam cal. Go to the File menu, Open, straight beam, okay, Open, Contents, Recall. Open, Contents, Recall. Okay, press any key to continue. Go back to the basic menu. Alright, so we've got our half-inch thick cal block. There's the 100 deep side drill hole. And here's our 300 thick notched block. There's the 210 notch. The depth to that notch is 90. Let's go ahead and look at that notch. I'm going to go ahead and set up the straight beam. I'm going to go to an unflawed area. It's 300 thick. I'm going to bring that to 80% screen height with auto 80 function. And then I'm going to add 6 dB. 70.9 dB. I'm going to add 6. That's a little sticky. There we go. 79.6. That's a good amount of gain to start out with straight beam. Go to an unflawed area, bring it to 80%, then add 6 dB. So let's take a look at this notch with the crosstalk barrier. Here's our crosstalk barrier between the sender and receiver sides. So I'm going to walk over the notch with the crosstalk barrier perpendicular. And I got a pretty good response from it, right around the first major division at about 100 deep. And let's see how that looks. Let's go ahead and add 6 dB to that so we can see it a little better. Alright. That looks pretty good. Alright, let's go ahead and turn the crosstalk barrier parallel to the notch. And although it's not quite as loud, I think that signal has much better resolution. It's a narrower signal. Let's add 6 dB. Oops. So this is something you want to be aware of if you're looking at seam flaws. If you can get on top of a seam flaw and use straight beam to get it, many times if you turn the crosstalk barrier parallel with the weld seam, it'll help you to get on top of the flaw. Alright, that's just an observation that you want to be able to use if you ever have the chance. Let's see what the side drill hole looks like. It's approximately the same depth. That notch was 90 deep, this hole is 100 deep. Actually, the top of that notch is 85. I have the crosstalk barrier perpendicular to the notch. Now let's see what it looks like when it's parallel. And the peak of the signal, I think, is a little narrower. I think it has better resolution. Anyway, there can be some significant differences when you're looking at actual seam flaws. All right, thanks a lot.